today we're graphing and finding inverses. We've already talked about logarithmic functions and exponential functions are inverses of each other, correct?
Yes.
We have in the past found inverses already. So we're just going to put those two things together. So the first thing we're going to do is we're going to graph 2 to the x and log base 2 of x on the same graph. You know that an exponential function goes through 0, 1, yes, and it goes up. So we're going to plug a few points in so we can get them. So if I plug in -1 to 2 to the x, what do I get?
-1 or 1/2.
I get 1/2. Okay, so there's 1. So I get 1/2. If I plug 0 into 2 to the x, I get what? If I plug 1 into 2 to the x, I get what?
2.
2. If I plug 2, I get what?
4.
I get 4. And so on, right?
Yep.
I plug 3, I'm going to get 8. If I come over here and I plug in -2, I'm going to get 1/4. Right? So I'm just going to keep getting down. It's going to come here. And it's going to go up. Correct?
Yes.
So this is 2 to the x. My domain is
All real numbers.
all real numbers. My range is
Y is greater than 0.
y is greater than 0. My y-intercept is what?
0, 1.
0, 1. Horizontal asymptote, that's nothing, right? Is y equals what?
Y equals 0.
Y equals 0. So those are the characteristics of that, correct?
Yes.
So I've already told you that logarithmic and exponential functions are inverses of each other. Yes? So that means, what does it mean to be inverses of each other?
Over the y equals x line.
They reflect over the y equals x line. The domain and range legitimately just interchange places, correct? So every point I could interchange. Let me put my y equals x line here. And go back to blue. Okay, so this -2 1/4 is going to go what?
Second, I need a red pen.
This point right here is -2 1/4. What is it going to go to?
-2, 1.
It's going to go to
1/4.
1/4 -2.
1/4. I thought it was 1/4.
No, this is 1/4. Okay, so it's going to go 1/4 -2, right? And this 1, -1 1/2 is going to go to what? 1/2 -1. And 0, 1 is going to go to
0 or 1 0.
1 0. The x and y are legitimately just changing places, correct?
Yeah.
Okay, and this 1 2 is going to go to
2 1.
2 1. And this 2 4 is going to go to
4 2.
4 2. So the graph is going to go like this. So what is my domain of this?
Y.
X such that x is greater than 0.
X such that x is, what is that? Is greater than 0. Because my range and domain are switching places, yes?
Yes.
Can you also see what's happening?
Yeah.
Yeah.
Can I plug negative numbers in here? No, we've talked about that already, haven't we? Okay, my range is going to be what?
Range is going to be all numbers.
All real numbers. I'm not going to have a y-intercept. I'm going to have a what? X-intercept. Of what?
1 0.
Of 1 0. I'm not going to have a horizontal asymptote. I'm going to have a vertical asymptote of x equals 0, because when we have vertical lines, they're x, right? So that's what it looks like. And for our next slide, when I go to our next slide, you don't have to redraw the graph. You could just write the equation, okay, guys? Because it's going to be the same. This is base 2, yes?
Yeah.
Is base 1 an exponential function?
Oh, it's linear.
It's linear, right? Because it's just 1, right? So the first exponential function we have is like 1. We can have 1/2 or 1/4 because that's just a negative exponent, right?
Yeah.
But we can't use 1. So our next base is going to be 2, 3, 4, 5, and so on. Can I have halves also? Yes. I can have log base a half. But sometimes we need to think of these in terms of the exponential to get the logarithmic when we struggle with that. What's going to happen if this goes to 8, log base 8? Is my graph going to be closer to the x-axis or further away from the x-axis?
Further.
What happens if I do 8 to the x?
Oh wait, it's gonna be closer.
8 to the x hugs the y-axis,
So
yes?
yeah, that's gonna be steeper.
So it should be steeper, shouldn't it?
For,
I don't know if you're going to be able to see green. It's still going to go through here, correct? But it's going to be like that.
yeah.
So this would be log base like 8. Okay? What if I said to the 1/4?
Then it's gonna go.
Then it's going to go, it's still going to go through this point right here, correct? And it's going to go further. It's not going to cross this line. Well, it could cross it. They would both cross it then, right? That's where they would intersect. It will cross it, sorry. I shouldn't say that. So log base 1/4. So the first 3 problems that you have, guys, you could honestly do them on one graph and then write the information next to the graph. Just label it. You don't have to make 3 graphs. See how I labeled them? Okay? Because 2 of the 3 will share everything the same. One of them will not. Okay, so we've talked about this. I'm going to put the parent function up here. I'm going to sketch the graph, whether you want to resketch the graph or not. You can. There's a lot up here, but there's really not a lot. If you look at this and you look at this, they're exactly the same. What's the difference in the bases? What's the base on the left? No, A. See, log base A?
Yes.
It's log base A. So that's any base other than what's on the right. E. Okay, so are they exactly the same thing? Yes. Yes. What is E? What number is E approximately, guys? 2.71828, right? So it's somewhere between 2 and 4, correct? Or 2 and 4, yeah, 2 and
Well-
3. 2 and 3 is what I wanted. So it'd be somewhere, it would lie somewhere between 2 and 3. Would it be closer to 2 or closer to 3? 3. 2.7 would be closer to 3, wouldn't it? So we need to know that it has a little faster change than 2, a little less change than 3, but other than that, is anything going to be different? No. And I promised you from day 1, every plus and minus H and K would do exactly the same thing as it always has done. Haven't I?
Yes.
Okay, so what does the first plus and minus do? What's it reflect over?
X-axis.
The x-axis. Okay? Log is my function, yes?
Yes.
A is going to tell me how steep or slow or whatever you want to describe it, right? What's this plus or minus reflected over? The y-axis. This is the x-axis. This is the y-axis. So the function looks like this, yes? And it goes through what point? What point's up?
1, 0.
1, 0. So if I were to reflect it over the y, it wouldn't go through 1, 0. It would go through what?
Negative 1, 0.
It would go through negative 1, 0. And it wouldn't be increasing, it would be what? Decreasing. So in that case, it does matter reflecting over the y, doesn't it?
Yeah.
And then you can reflect over the y and the x. How fun, right? What's this h do?
So move it left or right?
Left or right? Always the opposite direction, right? And what's the k do?
Right.
Work up and down. Okay? I promised you that they would always do the same thing. Are they still going to do the same thing?
Yes.
Yes. So, what is the domain of this? One more time. Of the parent, not this. What's the domain?
X such that X is greater than 0.
X such that X is greater than 0. The range?
Y such that Y.
All real numbers.
X-intercept
0, or no, 1, 0. 1, 0.
and vertical asymptote.
X is equal to 0.
So if I can't remember this, can I do the exponential and then just switch it over? Do the exponential, because you guys all got that down really well.
No.
Most of you do. And you can switch your domain and range, right? And then a horizontal becomes a vertical, and a y-intercept becomes a x-intercept. Because what do inverse functions physically change? What? What two things does an inverse function physically change? The x and the y, the domain and the range. They physically just interchange places. That's it. They undo each other. Are we good to go?
Yes.
Okay. Now I'm going to tell you the three. You only have three graphing. They are very basic. They are very basic. They do not even have an H and K. But I'm going to show you some H's and K's just so you know how to do them. Okay? So, do I have an H or a K?
You have a K.
You have a K.
I have a K. How do I know it's a K?
Up and down.
Because
It's
it's
outside of
not
the
in the
equation.
It's outside the parentheses. It's outside the equation.
Yes.
It's outside the equation. Or the function, we should say. So, we have this point that we know is 1, 0, yes?
Yes.
What's going to happen to that point?
Going to move up 4,
It's going to move up 4, so it's now going to be what?
5, 4. One of those two.
Up.
0.
Is X or Y up?
5, 0.
Is X or Y up?
5, 0. It's going to be 1, 4.
It's going to be 1, 4. Because Y is up. So let's do 1, 4. Okay. Is this going to be close to the x-axis or further away?
Closer.
Closer because it's
Camera,
1
right?
half.
Farther away.
Further away because
Because log 3 was higher than log 2.
Right. Because what happens when I take
Or
1
further
half
away.
to the x?
It goes back up
It
to
goes
over
back up,
here.
it's going to go, right? So this 1, 0 is going to go to what?
1, 4, 4.
No, it's going to be going 5.
Okay. So if I need to think of this to get some points, so my brain can get some points, I can do this, right?
Yes.
I can plug an x into this. So I plug in 0. I better get nothing, right? Because
Yeah,
I
you
can't
get
plug in
0.
0. Okay, 1. I'll plug in 1.
Yes. 1.
So if I get 1, I get 1 half.
Yeah.
Okay. If I plug in 2, I get what?
1.
1 4th. I'm squaring, right?
Okay.
If I plug in 3, I get
1
6.
1
8.
8. Cubing.
Oh, now 1/16.
Okay, so this is for this, but I want log. So what is it for the log?
It's going to be 4, 2, 4, and 8. No, it's not. But
1
It's
half.
going to be 1 half,
1.
1,
That is ball enough. Peter.
1
That's
4
all.
2.
1 4th, 2.
1 8.
Just stop, Tom.
Okay. So it's going to be, we're going to come here, and we're not going to cross over here, are we? We're going to cross where?
Down there.
And it's going to go, okay? That crick is going to happen where that 1 4 is up. Again, all of your things today are just going to have a base. Got it?
Oh, got it.
Okay,
Got him.
so I'm going to erase some of this stuff.
Now we can do the
Oh,
domain
you got
and
Yeah, and we can, but do we really need all of that?
yes.
Did any domain range change? Anything change?
No.
Wait, the domain.
The
X-
x-intercept changed, and that's it. Okay, but did domain or range change?
No.
No. Did increasing, decreasing change? No. Nothing.
No.
Okay, so what about, I need blue. Blue. Log base 9 of x.
There's no
It'll be
K.
close.
It's gonna be really close, right?
Yeah.
It's gonna go through this point, isn't it?
Above the line, yes.
Yes.
There's no H or K, and it's gonna.
It probably should have been closer than that, but respectively. Did you forget him? Donald forgot his again, third day in a row. Okay, so this is log base 9. Okay,
Wait, so why did you?
I'm just putting them on there so you can see the difference.
But how? Why is it gonna hug that line? What's that line? That
This
line's
is the
what?
x-axis.
No, not that. Like, why is it before 1? Like, why is it on 1?
Because it didn't move up or down. There's no K. Okay, log base 5 of x. Where's it gonna fall?
It's gonna go probably in the middle.
It's gonna still be here, right? But it's gonna be
Closer.
it's gonna be somewhere like that, right?
Yeah.
Yeah. Now, these aren't exactly proportional. What they would look like, are they?
No, ma'am.
No.
No,
But should I know? Should I know what goes between what?
Yeah.
Question. Okay. So that's basically your graphing, guys. If I threw in a negative, how about negative?
No solution.
What does the negative in front?
Over the
Yeah,
x-axis.
So it's not going to go up. It's going to go down. So it would go through that point still.
What?
I was so close. That'd be a negative log base 9, right? What's another reflection we could do? Oh, we could do the
Negative
y,
x.
right?
27.
Can we do the y? Over the y?
Yeah, negative x.
So let's do this one. So log
Negative.
base 5 of negative x.
That would be.
So it's not going to go through 1, 0. It's going to go through what?
Negative.
1, 0.
Negative 1, 0. And it's going to go which way?
Down.
It's going to go like that, isn't it?
Yeah.
Domain, is it going to change?
No. Yes.
Yes,
Yeah,
domain is
it's-
not going to be greater than
Look.
0 anymore. It's going to be
Less
less than 0 because a negative times a negative becomes a what? Positive. Okay? Got to get the gist of it, guys? This is about all you're doing. We're not
They're all
going to
in
use sheet.
for notes.
That's all graphing notes. Any questions on graphing? If I gave you any base, any reflection, could you do it?
I could do all of it.
Okay. So
No.
let's go to inverses, and it's going backwards. Okay. I like
What
the
was the
green.
green?
Can you
What was
even
the
see the green?
Yeah.
What was the green?
Just
Oh,
Another
log,
base.
log base 5.
The green was
Of negative x.
No, it's X used on that side. Can you guys see the green?
No, I can't see it.
Elena, can you see it back there?
I'm blind.
Yeah.
Okay.
I'm blind. I can't see it.
So, shush. Okay, if you're blind, I don't care. Okay, I want to find inverses. How have we found an inverse before in our world?
I want to say that
Y equals K over.
What two things interchanged?
Y
The X and Y. Isn't that what we did?
Yes.
Interchange them and solve for Y. So f of X is the same as what? Y. So it's now going to be, so I have f of X equals 10 to the X plus 1, right? So I'm going to have X equals 10 to the what? Y
the
plus
Y.
1? And the book doesn't put parentheses around that, but I would, so you remember it is one exponent. And it needs to look like an exponent on your paper. Because if it doesn't look like an exponent, are you going to treat it like an exponent?
No.
No. So, you went through this yesterday. This is what you did the last part of your assignment. You need to solve for Y now, correct?
Yeah.
Can you get to that Y?
Yeah.
Not in exponential form. So what do I need to do? Put it in a logarithmic form. What is my base? 10. And I don't have to put 10 there, but my base is 10, correct?
Yeah.
So log of what?
X.
X. Because these two have to interchange, domain and range have to interchange, right?
Yes.
So log of X equals
Y plus 1.
Y plus 1. And then what? Subtract 1. So F inverse, remember that negative 1, F inverse of X is going to be log of X minus 1. Now, could I also write it as -1 plus log of x?
Yeah.
The book will do that once in a while. Doesn't matter which one I do. The k can be in the front or the back.
That's ugly.
And that's all I have to do then?
The only time I usually put my k in front is if my log has a negative on it.
So that'll be the only way
That's
that's how we're doing that.
What? You can write it either way.
I like the
No.
first one.
Never mind.
Okay, so then do it again.
G of x.
At the bottom, like log x equals -1 plus log.
Can you not see that? You
I
can't see the
couldn't
green.
see that last part. I could see everything else. She can see it. She's
Okay, I can switch color.
No, that's not the
Switch it to blue.
This may be thicker.
Switch it.
Make it white.
Okay, so what do I do first?
switch your x with y.
Switch an x and y. So x equals,
Log base 7. Y plus 1.
oh yes, thank you.
And now it's gonna be.
Okay, so,
Don't you put it into exponential?
yep, we gotta put it in exponential, don't we?
It'll be
Ooh, that's
7.
yellow.
That's good. I like that one.
Thick yellow.
The thicky.
That's way thick
Still pretty
green.
thick.
Keep it thick.
7.
Okay, so what's my base?
7.
7 to what power?
None.
X.
X
Oh yeah, x.
equals no power.
No power. Equals y.
Y plus 5.
And then what?
You
Subtract
subtract 5
5.
from both sides.
So G inverse of X, or G inverse of G of X, either one you want to say it, is 7 to the X minus,
5.
I do not like how thick that is.
I like how thick. I wish. it
I
was
thought it would
thick.
be easier for them to see in the back.
Could it be thicker? It's not even that thick.
Okay, good?
No.
I get like those days here.
No.
Okay, next one I want you to do yourself. F of X equals 3, equals 3 to the X plus 2. Try it yourself.
No.
Yes.
We got one.
I got one.
Yeah, that's on the first one.
And then I wrote down the second one.
Callie, you want to help me with this one?
No.
No.
Austin will.
Taylor?
No.
Austin?
Yeah.
Okay.
Yeah.
What are you gonna do?
Oh, I don't want to help you
Austin, let's go.
Okay. So you just want me to tell you
Yeah,
what
just
I
tell
wrote?
me the next step.
X equals 3, and up top is parentheses y plus 2.
Okay.
And log, and your parentheses x.
Base what?
Hmm?
Log base what? What's my base?
3.
Of,
Equals y plus 2. And subtract 2.
okay, so F inverse of X
Yeah.
is log base 3
Yeah.
of X minus 2.
Yeah.
Okay, don't just let your base, guys, your base has to be there. I just showed you, right? It changes the rate. That rate of change.
Did it right. I'll do the
What?
next one. Did it right.
Good job.
can help you with the next one.
No, I just
Adelaide
so-
volunteered. Okay, this one's different. Adelaide, can you tell me how it's different?
Because you have to change it. I don't know what it's called. Is it the E one?
exponential?
I don't know. I changed it like this.
Okay, well, there's this one's different.
This
I
one's
changed
on
it
the
different.
Okay, tell me what you did.
Okay. Well, first I changed the x minus 2 to y minus 2.
Okay.
Okay, and then it's 6, and then
Wait, what?
x and like the exponential. I don't know how to say it.
Be careful. Is that 2 a K or an H?
That's a K.
It's a K.
Why? Okay.
Why
I
is
can
it
make
a
like
K?
I quit.
Why is it a K?
You just
It's not
that
in
works.
parentheses. So do you see the value of putting parentheses in there?
Yes.
Yes. Okay, the book tends not to do it. If it's not in parentheses, it's not there. It's a K. So can I switch this into exponential form yet?
No.
I have to, not subtract 2, but
Actually.
add 2. So I have x plus 2 equals log base 6 of y.
I'm mad. Burn it alive.
Okay, so I put that one there because we got to remember that. We in our brain just put a parenthesis. Everyone's brain put a parenthesis
I
right there,
wrote
right?
parentheses, I just thought you messed up, dude.
No, I
I need
didn't.
to rewrite this.
Okay, so now when you were talking about, she said the natural log. I would use natural log if it was e, right? Like e to the x or something. I would use natural log. Is that what you were trying to say, natural log?
I don't know.
Oh,
That
okay.
was just what I was doing.
Okay.
I don't know what it's called.
Okay.
I don't
So
want to do it anymore.
now I'm ready to go to exponential. I think you can help me, Adelaide. I think you can help me now.
Can I?
Yep.
Are you sure?
Yes.
Now do you subtract the 2 to the other side?
We go.
Yeah, we just did that. I don't. Yeah, now we switch it.
We know switch it. So what's my base?
6
To the what power?
x.
X plus 2
Mm-hmm.
equals. Oh, and then just g inverse of x, right? Because it would equal y.
Yeah.
There you go. You can't, remember yesterday when you had to divide a couple of them before you can change forms?
Yeah.
If there's anything outside the function, you have to move it before.
That's just the answer.
Yep, that's just the answer. It's written kind of backwards, right? But it's the
That's
answer.
weird. That's
Okay, so just remember you can't switch forms until it's by itself. It doesn't work. The other thing the book does not do is put parentheses around the exponent, and I would encourage you to do that to remind yourself that they are stuck together. They're one thing. Hmm?
The book is weird.
I know, I don't understand why books don't put parentheses. It's like they want to save ink. Like, I don't know. It's not when you're back in the printing presses where you actually had to put the parenthesis in there. You know, I don't understand. But anyway,
We just write parentheses in the book.
I know it's
You wanna
it's a
know
button. It's a shift button on your keyboard. Yes.
You wanna know what 6 to x plus 2 power is?
Well,
2, 1, 7, 6,
it's
7,
nothing.
8, 2, 3,
it's
6.
nothing.
What did you do?
Okay, it's nothing though. You have to assign a value to x. You can't put x. Guys, if you put x in your calculator, everybody's calculator has a value assigned to x, but we don't know what x is, do we? If you put just x in the calculator and you hit enter, it will spit out a number. I don't know. It just depends on the
I don't
calculator.
wanna find out.
Okay,
Yeah, I
So,
don't wanna find it.
just a second. Let's finish up so I can stop the recording before you guys all get sidetracked. Okay, so you are going to graph 3. Remember, I told you you could put them all on one coordinate plane and just write your range and domain stuff off to the side. If you put in the middle, it's really easy. 2 of them share everything. The other one does not. Okay? And then you have 5 of these. So get to work and get done.